All right, so Boyle's law is the pressure-volume relationship, okay? So pressure and volume are inversely proportional.
Are we supposed to be following along and so?
I'm going to give you some advice, background knowledge, give you some stuff to work with so you know how to solve the problems that'll be your ticket out.
Yeah, I know, but like, do we need to be following along on like a paper?
Not exactly follow along, but I am just going to give you a little heads up on Boyle's law, which is from your guided notes. Show you how to do some of the math calculations. Yeah. All right, so pressure and volume are inversely proportional. So graphically, it looks like this. If our volume is increasing, our pressure will decrease. If our volume decreases, our pressure increases, right? Which makes sense. I'm sure you guys have seen somebody take a bottle and they twist it and pop the lid. You know what I'm talking about? You never seen that before? An empty water bottle? They twist it right here and it pressurizes. Basically, you're shrinking the volume down. The volume gets smaller and the pressure builds. Then you flick that cap and it like pops off. We've seen that before.
Why not like
Look.
Why at the bottom it's like this?
Yeah, then you flip that top. Yeah.
Oh, wait, someone did that at lunch and everyone thought it was lunch.
All right, so here's, I'm going to give you a couple different approaches to how to solve these. So essentially what you have going on, you can say the pressure in the beginning, we'll call that pressure 1, and the volume in the beginning, we'll call that volume 1. That's going to be equal to the pressure after, we'll call that pressure 2. Can you sit down, please? Sit down.
I was trying to find it.
Can you sit down? Thanks. Appreciate you. All right.
I was just trying to find my
Volume 2. Okay? So, I mean, that's pretty much the equation you're going to use right there. P1 times V1 equals P2 times V2, where P1 is the original pressure, V1 is the original volume, P2 is the pressure in the new situation, and then V2 is the volume in the new situation. Okay? So let's tackle one of these problems. Give me a problem 17 through 24. 20. That's an excellent choice. So on 20, we have an air mattress has a volume of 114 liters in the mountains. When it is put in the pickup truck, the atmospheric pressure is 0.925 atmospheres. At the beach, the pressure is 0.975. What is the volume of the air mattress at the beach? All right, let's set this up. In the mountains, we have a volume of 114. So I'm going to call V1 will be my 114 liters in the mountains. 114 liters in the mountains. And we got a pressure of 0.925. 0.925 atmospheres.
So since the new atmosphere is like a higher pressure, I guess, couldn't you do the difference of the two atmospheres times the 114 liters?
I don't. You said the word difference there. I don't like that. You're really.
All right. So subtract the two atmospheres and then take the answer.
No. What you got to remember is these things are inversely proportional. So it's really a matter of either multiplying by a factor of increase or a factor of decrease.
Yeah.
So you're not really subtracting anything. You're multiplying by something to make it more or less.
Yeah, I know, but like to get the atmosphere, couldn't you subtract the two atmospheres and then multiply what you get by the liters and then add it?
We could try it your way. It might work. I guess I'd have to think about that a little bit more in depth. But basically, the difference would be what, 0.05. 0.05 times 114. Oh, maybe so. So anyways, at the beach, the pressure is 0.975, and they basically want to know what is the volume of the mattress on the beach. We'll call that V2. So essentially, you got the product here divided by this atmospheric pressure. So 0.925 times 114. 114 times 0.925 equals 105.45 atmosphere liters. And we're going to divide that by 0.975 atmospheres. And we get 108.15 liters. 108.15 liters, which makes sense, right? Our pressure got more, so it's going to actually make that volume of that mattress come down a little. It's going to like compress it in a little bit, so your volume should get less. Now, just curious, looking at that.
No, it's not.
Yeah, it's not. Yeah, and again, that's all about the proportions. It's all about like a factor of increase or a factor of decrease. Here we have a factor of decrease because, like, literally the air pressure changes as you come down to the beach. You have more pressure at the beach, so it's literally going to force that thing to get smaller. All right, let's tackle another one. Another one. Give me 17 through 24. 4. What? 17 through 24.
17? Oh,
Through 24.
17.
17. All right, here we go. We have a balloon filled with a helium gas. It's a volume of 500 milliliters at a pressure of 1 atmosphere. After the balloon is released, it reaches an altitude of 6.5 kilometers where the pressure is half an atmosphere. Assuming the temperature is constant, what volume does this gas occupy at this height? All right, so we have a changing altitude, which causes a change in pressure. All right, let's set this up. We have a, again, you're going to have, PV, P1, V1 equals P2, V2. All right, so our original pressure is going to be 1 atmosphere, and our original volume is going to be 500 milliliters. And so we have a change in pressure. The pressure actually drops in half. So it literally cuts in half. So our new pressure is now half an atmosphere, 0.5 atmospheres, and they want to know what that new volume would do. Now look, y'all can probably do this one sort of in your head, right? If your pressure is cut in half, and these two variables are inversely proportional, then what do you expect your volume to do?
Go down.
Inversely proportional.
Oh.
If your pressure drops, your volume's got to go up, right? By a factor of 2. In other words, if your pressure drops by a factor of a half, like it cuts in half, then your volume's got to double, right? And you can see this mathematically here. We're going to call this V2. That's what we're looking for, right? So we're going to have 1 atmosphere times 500 milliliters divided by half an atmosphere. And so you would have 500 divided by 0.5, which should be 1,000, right? Yeah, 1,000. ATMs would cancel. You'd have 1,000 milliliter balloon at that new altitude or at that new pressure. Right? So, I mean, think about it logically, right? Your pressure's dropping in half. That means your volume must have doubled. Jose, you can't be here, my man. I mean, I like you. I mean, me and you, Marietta, we go way back to period 7, but yeah.
Did the math